Go. Today we'll be talking about the second question of part B. A stone general is a chess piece that moves one square diagonally upwards on each move. That is, it may move from the coordinate a, b to either the coordinates of a minus 1 to a plus b, or b plus 1, or a plus 1, b plus 1. How many ways are there for a stone general to move from 5-1 to 4-8 in 7 moves on a standard 8x8 chessboard? So now let's look at this problem. The question itself can be solved by like just drawing the image. So in this case, we see that we can have a one creative solution. X is denoted as the number of possible steps to get into this box. So on the start place, we can mark it as 1 because there's only one way to start. Okay. So we can see since the problem states that we can only go northwest or northeast, we can go from either this part or this part. However, there's also only one way to arrive here, which for going from here, you can only go here or here. Then you can go to, for other places, since that it is very important for you to get to those grids, you can just write them as 0. Impossible. 0, 0, 0, 0. Okay, let's see the next one from here, right there. You can see that going from here, it only has one way to go from here, like one way here to here, which is here to here, and it also has only one way to go here, which is from here to here. However, there's two way. You can either to get to this part, you can either go like this from this dot to this part, from this part to this part. You can also go from this dot to this graph to this graph, and from this graph to this graph. So in this case, this one has the two ways. For the other graph, it is impossible to get to there, so we set them as 0. Now let's talk about the fifth line. The fifth line is like 0, 1, 0, 3, 0, 3, 0, 1. You can from here we can see this is important to get through. This one E2, it only has one way, which is from D3. F3. Okay, from here it has two ways, which is from here, which is one way, and from here this is two way. One way to from this. This. There's only three ways. And this is also the same as this one. This. From here to here, there are four ways. This. So there's four ways to get to here. To be honest, this question is quite similar to one AMC question that I've talked about. It's also giving you a starting point and asks you how many ways it goes to, it reaches to reach the destination point. This is quite similar to one of the AMC 8 questions that I have, like, talk to you guys in North America, Mexico. Let's go. You guys can think about which question it is. I think it should be question 4 or question 22 on 2018. I think it should be that question, but I'm not sure. Okay, so let's see the next line. This is 10406040. Now you're able to know how it is derived from. 3 ways to get here, 3 ways to get here, so it's 6 ways here. 3 ways to get here, 3 ways to get here, so it's 4 ways. 1 ways to get here, 1 ways to get here, 3 ways to get here, so it's 4. 1 ways to get here, so it's here. Okay, and we can go up. 5 is because 1 plus 4 is 5. 10 is because 4 plus 6 is 10. 10 is because 6 plus 4 is 10. 4 is because of the 4 here. For the other points, it is impossible. 0, 0, 0, 5, 0, 10, 0, 10, 0, 4. On the upper line above, it's there are different numerous ways. This one is 5, so it's 5, 5. It's 0, right? This one 5 points, 10 points, so it's 15 here. 10 points, 10 points, 20. 10 points, 4 points, 14. So in this case, now let's finally derive the uppermost line. 20, 14, 34. 14, 14. 15, 5, 20. 15 plus 5 is 20. 15 plus 20 is 35. 20 plus 14 is 34. So in this case, we are able to derive that the final destination to reach on the blue point specifically is 35. So, however, there's still another way to do it. Okay, so let's look at another way. We define the following thing. So we can observe this one. We can see that there's any point at D4, D8, and the starting point is at E1. So in this case, we can see there's only like horizontally, there's only 1 degree difference between the two. Horizontally, okay, 1 degree, 1 box horizontally different. In this case, um, from where we can go that we can know from where we can know that things that from where we know that there is x times we can go northwest, which is like here to here, and there is x minus 1 way we can go northeast. Because if we go northwest, we need to like go 1 grid left. If we go one right, it will if we go northeast, we'll go 1 grid right. Since the final like displacement between the starting grid and ending grid is 1 grid left. We can say that there is four. We have to go x ways left and x minus 1 ways right. Since we know that we need to like make operation for 7 times, one because from here to here we need to do one operation. From here to here we need to do one movement. From here to here we need to do one movement. From here to here we need to do movement, etc. We get 1, 2, 3, 4, 5, 6, 7. 7 steps. So in this case, x plus x minus 1 is 7, and x is equal to 4. Therefore, this means that we can go northwest for 4 times. We can or we have to go northwest for 4 times and northeast for 3 times. Therefore, the different possible combinations actually comes from the order of when we go northwest and when we go northeast that matters. So, in this case, we simplify this problem into a combinatorics question where we need to count the total number of total possible ways for us to go northwest for 4 times and northeast for 3 times for a total of 7 times. So in this case, what we need to do is just C7 4. 7 chooses 4. 7 chooses 4 because here's the thing. Why is it 7 choose 4, right? If what we are going to do is that we know that there's 7 spots. 7 choose 4 chooses the gives all the possible ways for the first 4 for the northwest to go. So for example, and after it decides all the possible ways, I mean the 4 locations that the northwest needs to go, the all other ones are all northeast. For example, if we choose this, right? The only possible combination left for east, northeast is only like this, and this. So in this case, we obtain the solution is equal to 7 choose 4, which is equal to 7 times 6 times 5 times 4 divided by 4 times 3 times 2 times 1 is equal to 35. In this case, the final answer is going to be 35, which is going to be the final answer. Here we come to the end of our lesson, and I hope you have learned a lot. See you next week. Sorry. Bye bye.